Do you ever wonder if you could take a CSV file and turn it into some Terraform infrastructure and do it all with for each loops and dynamic blocks? Well, we're going to cover all of that on today's Terraform Tuesday. Hey everybody, it's Ned Bellavance, Ned1313 on Twitter, and welcome to Terraform Tuesday. I'm recording this one a little bit late, but I'm going to try to get it out today. We're going to see what happens in the editing process, but I hope that I can do it. Thank you so much for watching. Today's topic is dynamic blocks and CSV imports and for each loops for resources. We're getting into all kinds of crazy stuff, and it's all because two different viewer questions. One viewer question asked me about working with CSVs, and the other viewer question asked me about dynamic blocks in the context of AWS Launch Templates. And I thought, you know what, two birds, one stone, let's do that. But before we get into that, got two quick things that I want to plug. Number one, if you haven't checked it out, my Terraform certification guide is about to be updated for version 1.0. I got to push out the publish button tonight. It's already written. I just actually need to publish it. But if you haven't already purchased it, go ahead and purchase it. You'll get updates for free. If you have purchased it, thank you so much. And you will get the update if you haven't taken the associate exam yet. The updates are in there. You can find the link down in the description. That's one thing. The other is I'm trying to grow my Patreon a little bit. So if you're interested in supporting me on a monthly basis, we've got a few different tiers you can go for. If you start at the smallest, it's only $2 a month, and you get a weekly newsletter from me, which is kind of nice. So please check that out as well. That's also down in the description. So with no further ado, let's talk about today's topic, dynamic blocks in the AWS Launch Instance template. All right, like I said, this was based off of two viewer comments that I had. And so just to go show you, I do in fact read the comments that come in. And one of them was asking me, hey, I want to use dynamic blocks inside of AWS Launch Instance templates because you can define one or more block devices inside of the instance template, which means you can have more than one EBS volume or any other type of volume that you wanted to mount on your instance. So I want to use a dynamic block and bring in information and parse through that. Okay, so that was one request. And the other request was, hey, you mentioned working with JSON, and I actually did a whole video around parsing JSON with Terraform, but what about parsing CSVs? Because sometimes you get data in from CSVs, and if you don't believe me, just remember, Excel is still one of the most popular business management applications out there in the world. Data comes from Excel all the time, and people export things as CSVs, and sometimes you just have to deal with that data format. Now, I will say there's like two options here. You could take that CSV and use Bash or PowerShell scripts or Python or whatever to transform it into something nicer before you give it to Terraform. And actually, that's probably what I would prefer to do. But with that said, if you wanted to use Terraform to massage the data, we'll see how that's possible in the example. Now, in order to understand what's going on in this example, I do recommend checking out my dynamic blocks video because that includes all the information you'll need to understand how to craft a dynamic block and how they work. I'm not going to get super in depth with that in this video because I really did want to focus on how it works with the launch instance templates and then also how to work with the data in the CSV. And for fun, I threw in a separate JSON file because maybe you get that from your network team and maybe you get a CSV from your application team and you got to use both in your Terraform config. You can do that, no problem. So let's go over to the code. Let's check out what's going on in VS Code and we'll walk through my example. All right, here we are in VS Code, and we are in the folder 2021-0803 EC2 dynamic blocks. That's a pretty good description of what we're working with here. And let's start by looking at some of the files we got here. We've got a network data.json file, we've got a values.csv file, and then we've got some Terraform files. Why don't we start with the CSV file and see what's in there? So I'm gonna go ahead and open up values.csv. And this is a CSV format that I just kind of made up, but this is probably not too far from what you might get from an actual business unit or application or a service desk ticket or something like that. What do we got in here? Well, we want to create one or more instance template groups. So we've got a group name to start off. Okay, cool. And then we have an instance type. Awesome. Tells us what instance size we want to use, instance type. And then we get into the AMI, the image ID that we want to use. Now, in this case, that image ID, that AMI, is actually the Amazon to Linux ID for the US East 1 region. We're not actually going to deploy anything. I just wanted to put a valid value in there. But you might get a different AMI for each different group that you have in your CSV. Okay, now the next thing, and this is a problem when it gets into the world of CSVs, creating complex data types is really outside of the wheelhouse. If you want to say, I have a list of disks and each disk has multiple properties, in JSON, you can create a list of maps. And then you can just define each thing in that list. But with CSVs, you can't really do that. And the solution that I've seen all too often is to have, well, you know what, Max, we're going to have 3 disks in our configuration. So let's just do a column for disk 1 size and disk 1 perf. We'll do one for disk 2 size and disk 2 perf and disk 3 size and perf as well. Okay, and then down in the actual values, let's walk through one. So we've got our web group here. This is going to be a set of web servers. They're going to use the t2.medium instance type. And then the AMI ID, I already talked about that a little bit. Disk 1 size is going to be 40 gig. We're going to use the GP3 disk 1 performance. And then for disk 2, we've got a 10 gig volume that's going to use GP3 as well. And then you can see we've got zeros for disk 3 because it's not going to have a disk 3. So remember that we're going to have to deal with those zeros. How are we going to deal with that? And this is a pretty realistic example of something you might get from somebody else. Whereas something like DB1, that for instance has disks for all 3. So now, okay, our DB1 is good. We can use all 3 entries there. All right. Now, how are we going to interpret the CSV? Well, the first challenge is getting the information in your CSV into Terraform. And fortunately, it's not as much of a challenge as it might first seem. Let's go ahead and open up the compute.tf file. All right, this is the compute.tf file that's going to create our launch instance templates. And we're going to massage the data a little bit in our locals area. So locals are local values in Terraform. It's sort of like variables in another language, but variables are input variables in Terraform. So we call these local values instead. The first thing we need to do is get our CSV data, remember? And fortunately, there's a function called CSV decode that exists in Terraform. So all you have to do is load the file contents using the file function from values.csv and then use CSV decode to get that information into a local value called CSV data. Now we can work with that CSV data. Now you might be curious, how does it structure the data once you import it? What is CSV decode actually doing? Good question. We're going to use the magic of Terraform console to find out. Now, if you've never used Terraform console, it's pretty awesome. What it's going to do is launch an interactive console, and it's going to use the configuration of the directory you're in when you launched Terraform console. So you have to run Terraform init first, so it initializes everything about the configuration. It gives you access to the local values that are in here, and if you've actually deployed anything, it will give you you'll have access to those values as well. We haven't deployed anything here, so let's just take a look at what's in our CSV data local value. And we'll access that by doing local and then CSV underscore data. So that's the data structure we're trying to access. What does that look like? Okay, it's a little hard to see, so let me pull this up a little bit. And you kind of get an idea of what's going on here. It took the header row. If we look at our values.csv, here's the header row across the top, and it used those as the key for a map, and then it used the values in each row for the values corresponding to those keys. And basically, if we scroll up to the top here, we can see it created a list of maps, and each map corresponds to a row from the CSV. So that's the data we're working with. All right, now we need to massage that data a little bit. The first thing I want to do is I want to pull out the group name and use that as a key to refer to the map that contains all of my information. The way I'm going to do that is using a for loop. Now, if you've never used for loops in Terraform, I'll try to explain them. I also did a whole video on for loops, but I'll explain it here. The first thing about for loops is you have to tell it what data type you want to return. and you tell it by encasing the entire for loop in either curly braces if you want to return an object, a map, or square brackets if you want to return a list. In this case, we want to return a map where the key is the group name and then the value is the map that we're currently iterating over. Now, what do we want to iterate over? Well, we start out with our for keyword, and then K is going to be the value that we can work with throughout the loop. And where are we pulling that value from? We're pulling it from the entries that are in local.csv data, which is a list. So each iteration is going to be the next item in the list from CSV data. And then we want to transform that in some way. We're trying to get a map back here. So the key is going to be k.group. We're going to use the group name as the key for the map. And then the values inside the map are going to be the map itself that we're getting from CSV data. Now, if that sounds a little confusing, let's see what that looks like. We can use the magic of Terraform console, and we can do local.data_map. And when we do that, we see now we have a group named web. And inside that, the value for that is a map that has all of our values. Okay, this is kind of useful because now we can easily refer to a specific group by just referencing the key. That's going to be critical later. Okay, now what about the disks? The disks are a bit of a challenge because we have up to 3 disks, but they all have different names. It's hard to iterate over. The easiest thing to do would be able to create a list for disk 1, a list for disk 2, and a list for disk 3, and then we can put all those lists together. And that's exactly what we're going to do here. And we're going to do that with another for loop. You knew this was coming, right? Now, the data type we want to return is a list. So you can see we're using the square bracket in our for statement. And then the thing that we're iterating over is our data map, where we have the group name as the key, and then the rest of the values as the map as the values. So that's the thing that we're looking at right now, this whole web with the disk 1, disk 2, disk 3 information. So we're going to iterate over that local.data map, and we're going to use the values K, I won't say the values, the iterators K and V, so we can refer to the key and refer to the values of the item that we're currently iterating over. Within this list, we're creating maps. So we're creating a map for each disk. And the map will have the following key value pairs. Group will be equal to the group. Disk size will be equal to the disk 1 size. And we do v.disk1 size to refer to that value. Perf will be v.disk1 perf. And then device name, since this is our first disk, we can call it dev/sda1. All right, awesome. Now, the last thing I have in here is an if statement, and this makes the creation of that map element optional. It's going to check to see if v.disk1 size is not equal to 0. If it's not equal to 0, create the entry. If it is equal to 0, skip it. Now, all of our groups have a disk 1, so it's not going to skip it there. But when it gets to disk 2 or disk 3, then it might skip the creation of it. And that way we can filter out where the zeros are. So let's take a look at disk 1 list. So we'll do local.disk1_list. And this looks right. We've got a list of maps here. And in each map, we've got the group, device name, disk perf, and disk size. And we've got them for, it looks like, all of our different groups. Okay, let's try the same thing, but let's scroll down a little bit here and we see we've got disk 2 list, which uses the disk 2 properties, and disk 3 list, which uses the disk 3 properties. Now we know not all of them have a disk 3, so let's do local.disk3_list. And now if you look at this, there's only 2 entries in this list, one for app1 and one for db1, because the rest of our groups don't have a 3rd disk. Perfect. All right, now we've got our 3 different disk lists. Let's put them together into a massive list called all disks, and we'll use the function concat and just feed it in each of those disk lists. It'll create one big list, and if we do that, we can do local.alldisks. And we've got our list of disk maps. Perfect. So we've got our list of groups, and we've got our list of disks. And now we're ready to create the AWS Launch template called Taco Machines. All right, so we've massaged all of the data to where we need it, and now it's time to actually create our AWS Launch template. Let's get into how we're doing that. So I'm going to shrink this down a little bit just so we have a little more room to view things. And we're going to create multiple instances of this AWS Launch template based off what is in local.data map. Remember, that's the full list of all of our groups. So we're going to use the for each keyword here, the for each argument, to say I want to create multiple instances of this launch template. And the thing that I want to iterate over for that information is local.data map, which is a list of maps, basically. And then the next thing, the way that you refer to items, the way that you refer back to items in that thing you're iterating over is by using the each keyword. And because we're iterating over a map, we have access to the key and to the value. So each.key is what we're setting the name prefix to. And if you remember, the local.data map, actually, let's just, take a look at local.data map. I'm going to copy that, paste it down here in the console. We can see the key in local data map is the group. That's the name of the group is the key there. So our name prefix is going to be the group followed. And because of the way name prefix works, Terraform will add on some random stuff after that for the actual name of our instance of our launch template. Then for image ID, we want to go into the values here. So we're doing each.value and then the element we want out of that map. So image ID in this case, which we can see below, corresponds to an AMI ID. And each.value.instance type gets us the instance type we're using for proxy in this case. Now, coming up next, we've got the dynamic block. And a quick reminder on what dynamic blocks are. Sometimes you're going to have a nested block inside your resources that you can create more than one of. For instance, in this case, we can create more than one block device mappings block because you might have more than one block device inside your instance template. Now, instead of manually creating those, you can use a dynamic block to do that. So you use the keyword dynamic, and then the name label block device mappings tells it which nested block you want to create multiples of. Then the next thing is for each tells Terraform, okay, what do you want to iterate against to create these multiple blocks? And in this case, we're going to do something fun. We're actually going to pass it a list. So we've got those square brackets there, but we're passing it a list from a for loop. And that for loop is going to iterate across local.all_disks. Remember, that's our list of disk maps. And we're going to use the disks keyword to refer to that list in our for loop. And really, we're returning the full list of disks, but we've got an if statement in here. And we're doing a comparison. If each.key, that's the group name, is equal to disks.group, awesome. I want you to include that in the list that you're iterating against. If it's not in there, don't iterate against it. So that's perfect. Now we've filtered the disks that we're iterating against in our list based off of what group we're currently on in our larger for each loop. It sounds a little confusing, but that's what's going on here. And then the content keyword is what's the actual content of each dynamic block that I'm creating. And in this case, our content is going to be the device name. Now, to refer to the item that we're iterating over, you can either specify an iterator name or you can just use the name label from the dynamic block you're creating. So I just went with the name label, which is block device mappings. And then we do .value to get a value out of this list. And then we're using device name to set the device name. And then inside the EBS nested block, we've got the volume size and the volume type. Volume size is set to disk size and volume type is set to disk perf. Okay, so that is the dynamic block, and that's how we're going to create multiples of this instance template. Now let's get out of the Terraform console, and I'm going to go ahead and run a Terraform plan. I don't plan to actually deploy this, but let's run Terraform plan and see what the output looks like from Terraform plan. So let me just almost hide the code entirely, and we can see it's going to add 24 new things. Whoa, that's a lot of things. But let's kind of take a look at one of these entries here. So I do have a VPC in here. Let's not worry about that. Let's scroll up to our instance templates, route table association, scrolling up. And here we go. All right, so here is an example of our launch template. This is for the web group. And in there, you can see the image ID. We can see the instance type. And then we get into the block device mappings, and we can see it's got one block device mapping for SDA1, one block device mapping for SDA2, and that's it. It just created those 2 block device mappings that we wanted. If we scroll up to another one here, what do we got? We've got the proxy. And the proxy only has 1 block device mapping. It only has a single disk, and so on and so forth. So we can check our math here by running Terraform plan and seeing that the dynamic blocks that we wanted actually turned out the way that we wanted. All right, I did briefly mention that I've also included some JSON in here for fun, and I'm not going to put that into the video. I just want to point this out. I do have this network data.json file. Let me hide the terminal. And it defines a VPC, some address space, some subnets, NAT gateway, and tags. And that is being used by this, where is it? Networking.tf file, which brings that information in using the JSON decode function, and specifically the .vpc portion of the JSON. And then it can use that JSON information down in the configuration for the VPC module. So you can see, for instance, CIDR is equal to local.vpc JSON data.address space, which then corresponds to, if we look in the JSON, the address space that's under VPC address space. So if your networking team gave you a bunch of JSON and your application team gave you a bunch of CSV, you can use both of those in Terraform without any trouble. All right, in today's video, we walked through the process of importing a CSV into Terraform that you might get from who knows who, and then using that information, massaging it as you needed to. We needed to do some work inside Terraform to get our data ready for the resource we wanted to create. We actually wanted to create multiple instances of the AWS Launch Template. So we created multiples of that, and then within that, the dynamic block for block devices, we created multiple of those. So really got down into the weeds a little bit there. If you're the viewer out there that requested this particular piece of information, hopefully I answered your questions, or maybe I gave you a whole bunch more, who knows? But that is going to do it for me for today. As always, thank you so much for watching. I really do appreciate it. If you don't mind subscribing, that means a lot to me. If you want to leave a comment for a future video that you want to see or questions you might have, I do try to get to the comments as they roll in. And if you want to support this and other projects I have going on, you know, I did mention the Patreon at the beginning, but I also wanted to pop up the Patreon names and give them their due as well. So thank you to my wonderful patrons for helping me out. And that's going to do it for me for today. Thank you so much. Until next time, stay healthy, stay safe out there. Bye for now. I don't know if you know this, but I have a daily podcast. It's about 10 minutes long. It's called The Daily Check-In. Oh, there's a link down in the description for it. And tomorrow I'm going to tell quite the story of how I went through 3 different mice in the span of 3 weeks, and it all came down to severe user error. So if that's interesting to you, tune into The Daily Check-In tomorrow, Wednesday, to see what the story was about all these mice and what happened. And I'm even going to talk about this crazy vertical mouse that I bought. That was the last one in the series before I went back to my favorite, my baby right here. This is the mouse that I love. Okay,